Now, today we're going to start looking at solving equations with indices in them. And in particular, the unknown value is going to be in the power in these questions. So the unknown value, or the variable, in the power. We're going to start with a really powerful fact. If I have something to an unknown power, and it's equal to that same base number on the other side, I can ignore the base numbers and straight away say that x is equal to 3. So this is it looks really obvious when we look at something like this. If you have an equation with only 2 terms, and you have the same base, remember the base is the big number here, the same base on both sides of the equation, that means that you can put the powers equal to each other. You can equate the powers. That's the word that we're going to use. We can equate the powers. Let's look at an example that's slightly more complicated. If we were asked to solve for x, 5 to the power of 2x plus 1 is equal to 5 to the power of 3, like this. Well, I have an equation that only has 2 terms. We're kind of ignoring counting the power as part of this term. So this is one term, and this is the second term. So 5 is my base number on both sides, and therefore I can write down that the powers are equal. 2x plus 1 is equal to 3, which means 2x is equal to 2 and x is equal to 1. That's what it's saying there. Okay, this doesn't work, and it's really important that we note this. This doesn't work if the bases aren't equal. So if we have something like 3 to the power of x equals 5 to the power of 7, we can't use the laws of indices to solve this. So we have no way to solve this with junior cert maths. We can solve this, but we've no way to solve it with junior cert maths. So they can't ask you something like this because the bases aren't equal, okay? So we can't say that x is equal to 7 in this case. It also doesn't work if you have more than 2 terms. So for example, if I have 2 to the power of x plus 2 to the power of 3 equals 2 to the power of 7, I can't solve this either. So I also can't solve this without a calculator. So we need to have only 2 terms, and we need to have the same base. That's really, really important. Let's do one more example with these, and then I'm going to ask you to do a bit of practice with this before we move on to harder examples. And this is the hardest thing we're going to do in indices, really. So example solve for x. Okay. The first question is, if I have 2 to the power of x equals 8. Second, if I have 10 to the power of x plus 1 equals 1000. And the third one we're going to do, if I have 3 to the power of 2x minus 1 equals 1/3. Okay, so I definitely only have 2 terms in these equations, but they're not all to the same base. So the first thing I have to do is change them all to the same base. And this is just like questions 13 and 14 from your homework last night. So that's why I was saying that these were really important. So in the first one, I want them both to be to the same base. Well, what base? Well, hopefully it's obvious because you've learned off your perfect cubes that we can write 8 as a 2 to the power of 3. But if you weren't sure, could you write this as 8 to the power of something? Not easily, okay? So I'm going to write them both as 2 to the power of something. So 2 to the power of x is equal to 2 to the power of 3, and now I can apply my magic law and say that x is equal to 3. And that's it. It's as simple as that. The next one, again, they're not to the same base, but 1000 can be written as 10 to the power of 3. Remember our cubes. So that means that x plus 1 is equal to 3, and x is equal to 2. This one, a little bit trickier. I have 3 to the power of 2x minus 1 on this side, and 1/3, as we learned when we were doing question 14 last night, can be written as 3 to the power of minus 1. So now I can put the powers equal to each other. 2x minus 1 is equal to minus 1. So 2x is equal to 0, and x is equal to 0. And that's my answer there. So once you're done with that example, and you've taken those notes into your notes copy, I do want you to do a little bit of practice, and we'll do a little bit more with this again tomorrow. Thank you.